Hello guys and welcome back. Let's just quickly remind ourselves of what we summarized previously before we start sketching some functions here. We said if A is positive, we know that we're going to see a happy face on the Cartesian plane or a cup, all right? And then we said if A is negative, we're going to see a sad face and we are having a maximum point there. In the case of a happy face, we're having a minimum point. And then, of course, few things, the domain, unless indicated otherwise, really, it will be your set of real numbers. And then the range now depends on the value of Q that you've got there. So I had to write Q here. I'll fix this in my notes. And then that also has to be Q. I'll fix that. But this one are absolutely correct. They are fixed. So this is what we have discussed so far. Now, let us get into the real business, that is sketching the parabola. There are about 4 steps that you will follow if you want to do this my way, of course, to sketch in general any graph in the form y is equal to ax squared plus q. If you want to sketch a graph in this form, first of all, my advice, start by determining the domain and the range so that you've got a clear picture of how big your scaling has to be when you have to draw the axis yourself. And even if you are using a graph paper, you get an idea actually of where your biggest point label should be on the x-axis and the y-axis, all right? Very important. That's why I suggest you start with the domain and the range. Secondly, find the intercepts with the axis. And you know from the linear function, as we discussed, for intercepts, you must set x equals to 0 if you want to find the y-intercept. And if you want to find the x-intercept, you must set y to be 0. After that, determine what we call the axis of symmetry. I spoke about symmetry in that video where you had to complete a table, but we will explain it once again here. And then finally, find your turning point. You kind of know exactly how to do this. It's just that now I'm making it all formal and procedural. So follow through with me so that you can digest this. Let's get into it. Here is a worked example, and you are supposed to sketch the graph of y is equal to 2x squared minus 5. So I've already, of course, written this down so that we save some time. The domain, as expected, is the set of real numbers. So meaning if you take any real number and substitute it into this equation, you are actually going to find a value for y, all right? The range, to find the range, guys, you can do this algebraically. This is the beauty of algebra. First of all, we consider, okay, we're dealing with x squared here, that is a quadratic function. We know that x squared will always be positive. That's our statement. That's why we start there, okay? So x squared is always, or will always be, positive. Therefore, whatever you multiply x squared by, and in this case it's 2, so we are indicating, so 2x squared will also be positive because x squared is always positive. Finally, we have to subtract 5. So what we're doing basically on the left side here of this inequality sign, we are actually making it to match what we are given, right? And of course, what I do on the left, I must do on the right. And you may ask, Mr. G, didn't you do that? I did it there, obviously. It's just that anything multiplied by 0 is 0, okay? So now I subtract 5. Now you see 0 minus 5 is a negative 5. So now we can see that, oh, okay, actually this function is going to be greater or equals to negative 5. So it is actually going to move. So your range is actually y greater or equals to negative 5. If you want to write this in interval form, you will say negative 5 to infinity, sorry. Now, didn't Mr. G tell you that when a is positive. In other words, when you are having a happy face, you are actually going to have a range where y is greater or equals to q. Let's go back to that. Here it is, happy face, the range y is greater than or equals to q. So you can see that summary really works out quite well. So we have found the range, we have found the domain. Let's move on to find the intercept. So I'm going to start with the x-intercept here, and I need to set y to be 0. There it is. And then I just solve for x in this equation. And fortunately, you did this very well in grade 9. You know, because this is quadratic, meaning exponent 2, you will expect 2 solutions. And that is why here, even when I take square root, I don't just stay where I have 5 over 2, but I have plus minus, because this thing, the fact that this thing is a quadratic means I'm going to have 2 solutions. In this case, I'm having the same number, but not equal. One is negative, one is positive. And so I use decimals in this case because I need to locate this on the Cartesian plane. All right, I need to locate it on the Cartesian plane. That is why I'm using decimals. And then the y-intercept is simple. You just set x equals to 0. And if you substitute 0, you're going to have what? A negative 5. So actually, if we were to write coordinates here, let's say this is coordinate A. Coordinate A will be a negative 1.58 and a 0. Here, coordinate B will be 1.58 and a 0. And here, let's call this coordinate C. It will be 0 and a negative 5. So we've got 3 points that we can actually now plot on the Cartesian plane. Finally, determine the axis of the symmetry. Now, there is a condition for this. The condition is that 1, x should give you the same y value for some value k when k is positive and when k is negative. In this case, we can see that the 0 holds. So, in other words, the y-axis is the axis of symmetry, because in the y-axis, another name for the y-axis, I have mentioned this, I told you when we were discussing linear functions, the other name for the y-axis is to say the y-axis is the line x equals to 0. Remember, this is a line, okay? This is a line, guys. This is a line with an undefined gradient. Remember that if we want to take a step back to analytical geometry, undefined gradient. All right. So just a quick lesson here. You can never run away from, or rather, you cannot isolate mathematics topics. They are intertwined. They are linked one to another. So just because you are done with analytical geometry or the linear function, it doesn't mean you should forget what you learned. You must actually be able to remember and bring it into play as you discuss new concepts, right? Finally, the turning point. Remember, you either have a happy face or a sad face, and that maximum in this case and the minimum is actually your turning point, all right? So the minimum value of negative 5 at x equals to 0 is what we have. Therefore, the coordinates of the turning point is 0 and a negative 5. Now, if you've got a nice scaled axis or a graph paper, you will get a graph that looks like this. And you can see here is my A, the coordinate that I spoke about, there's B, and here is C, the turning point, and you can see we have a minimum. Does it make sense? Yes. Why? Because A is greater than 0. What is the domain? We have established X is in R, and what is the range? Y is just greater than or equals to Q, and Q is negative 5. And there are our intercepts, and there's the graph. And you can actually kind of use a freehand kind of drawing here, because all you'll just be doing is to join this intercepts. And what is important to note here is that this graph, that as it goes up, it's actually up to infinity. It does not stop going up. It goes up and up and up. And you can see as it goes up, there is a positive gradient here. I hope you can see that. And you will study this nicely in grade 12, okay? Don't worry. But you can see there is a positive gradient there. And you can see here there is a negative gradient. What I want you to get is the fact that it makes sense for domain to be the set of real numbers, because this thing, as you move up the y-axis, you will see that it gets to include this x values up to infinity, and you'll see it also these x values this side up to infinity. I'll leave it here for now. Cheers.